Okay, as we do harder logarithmic equations, which is what we're going to do here, we're going to need a couple of tricks, and then we're going to need the three properties of logarithms. And after I get done talking about them, I advise you to write them down because I'll probably erase everything, okay? So, if the log of q equals r, and q and r can be any expression whatsoever, then b to the r equals q, b to the r equals q. Well, that's just our equivalent statement. We're going to use that. We're going to have to use that. Another one that we're going to use is if the log of q equals the log of r, where both are at base b, then q must equal r. In other words, we can just eliminate the logarithms altogether right there. Now, the three principles of logarithms, which I think I proved one of them on one of my previous videos, I'm going to get around to the other two sometime, okay? The log of x times y is the log of x plus the log of y. In other words, this product can be turned into a sum, and notice the bases are all the same. Log of x over y equals the log of x minus the log of y, and the log of x to the y power is y to the log of x. And it goes backwards too. If you have a sum, you can simplify it into one logarithm. Difference, you can simplify it, and this you can bring the exponent inside. Okay, I'm going to do one a quick one right here. And I'm going to erase all this, okay? Now, I hope you got it down. If not, just back up and copy it all down, because you're going to need that in order to do these next two. Here is the log base 2 of x equals 1/2 the log of 81. Base 2. We've almost got the situation where the log of r equals the log of q, and we could just eliminate the logs, but we've got this 1/2 here. But I can use property 3. Remember the three properties? I can bring the exponent inside and go log of x base 2 equals the log of 81, 81 to the 1/2 power, like that. Now we have the log of q equals the log of r. And so we can immediately write x equals, base 2 by the way, 81 to the 1/2 power. Well, that's the square root, so x equals 9. So that's not too bad. We had to use one of the properties, the third property, and then we got the log into the log of q equals the log of r. We could just eliminate the logs. Okay, here's another one. ln x equals ln 144 minus ln, I may as well put parentheses here, it doesn't matter though, 16. Okay, now we have neither situation where we can eliminate logarithms, but if we use property 2, we can change this into one logarithm, and I can write the log of x equals the log of 144 over 16. Well, now we have the log of q equals the log of r, so I can immediately write x equals 144 over 16. And 16 goes in there 9 times. 9 times 16 is going to give me 144. So we have the answer x equals 9. All right. Now let's do a tough one, the kind you might see on a test and not know what the heck to do, right? And okay, here's one 40. This is let's say this is 42 in my notebook, and it's the log of x plus 3 minus the log of x minus 1. Hope I have room here. Log of x minus 1 equals 1. Okay, so that equals 1. All right, well, we've got a problem here. Again, we've got a situation where we don't have what we like to have, which is the log of q equals the log of r, or the other equivalent statement. But I notice that this is property 2 again. Oh, by the way, this is base 10, base 10. And so I can immediately write this as the log base 10 of x plus 3 divided by x minus 1. Remember, if this were a plus, then we'd multiply it we'd have a product, but we don't. We have a quotient here, and this equals 1. Now I have the log of q equals r. The log of q equals r. So I can immediately go 10 to the 1 power equals x plus 3 over x minus 1. This is a rational equation. You multiply both sides by x minus 1 and you get 10 times x minus 1 equals x plus 3. Multiply 10x minus 10 equals x plus 3. And when I bring the x's over, combine like terms, I get 9x equals 13. And of course, x implies that x equals 13 over 9. And that's what x is.